Hello, students. Today we'll be working on a new base that we're going to use. This base is the number e, and we'll introduce natural logarithms. So e is the number 2.71828, continues on forever like pi does, and that will be the base of a new type of logarithm that uses, instead of log, we use the letters ln. So the natural log of x has a base of e, and when we have a positive exponent on the e, we get growth. When we have a negative exponent on the e, we get decay. So we'll go back and forth on solving. Basically, if you have e as your base and you're solving for the exponent, you need to use a natural logarithm. So let's go ahead and calculate this. We would start with our exponent. So 4x equals, and then I'm going to erase that so we can see the rest of it. Then your base is e. That's where we'll use natural log. So the natural log will get rid of the e, and then we'll be taking the logarithm of our answer of 15. So this will be a numerical value, and then you'll solve for x. Now really, to solve for x, we need to divide both sides by 4. And I'm showing you this because we're asked to give an exact answer. So the 4's will cancel, and we'll get x equals the natural log of 15 divided by 4. This is the exact answer. In other words, we have not gone to the calculator yet to figure out what the decimal is. And then the decimal answer will be rounded to 4 decimal places. So we'll do that next, going to Desmos and calculating the natural log of 15 divided by 4. To get to the natural log, you will go to Functions, and then notice that you have to go over to Miscellaneous. You'll choose ln, and it was the natural log of 15. Close that parentheses, and then we want to divide all of that by 4, and then 4 decimal places, 6770. The number after the 0 is a 1, so we're going to stop there. 0.6770 is what our approximated answer is. So 0.6770. And we'll do a second one. Your next problem has an exponent of 3x squared. We make that just a little bit bigger for us to see. So 3x squared will equal, and then we're doing the natural log, that's what removes the e, of 500. So to get the x by itself, we'll need to divide. So we'll divide by 3. Now, in this case, it's not just x yet. We have x to the second power equaling, and then it's our natural log of 500, and all of that divided by 3. To remove an exponent, we square root both sides. So we'll square root both sides, and when you do, you get 2 answers. You get plus or minus. So that makes us have x equals plus or minus the square root of the natural log of 500 divided by 3. This is what we would consider to be the exact answers. There are actually 2 of them. And then for your decimal answers, we'll have the positive one and the negative one. So I'm going to go ahead and put 2 blanks to fill that in. Notice that we're going to need to do a square root of the natural log of 500 and then divide by 3. So your square root button, if your keyboard is not showing, you'll have your keyboard, the square root, whoops, let me do that again, is on that bottom row. Put that in first, then the natural log of, I need to look again, natural log of 500 and then divide by 3. So 500, those are parentheses, and then make sure that your division also goes inside the square root. So make sure that square root covers all of this. And so all of it divided by 3. 1 point, we're going 4 decimal places. So 1.4392. Now there's an 8 after the 2, which is going to round this up to a 3. 1.4393. 1.4393. I want to write this in. And we have both a positive and negative of that. So positive and negative 1.4393. Now, by the same token, you could have logarithm equations that need to be solved. And so if your equation starts with a logarithm and you have to solve for the variable inside that logarithm, you'll need to make a conversion to an exponential. So the base of the natural log is e, and that's what we're going to start with. So e, and then this is your exponent. E to the 3rd power is going to equal whatever the argument is. So that will equal x. So in other words, x equals e to the 3rd power. That is the exact answer because e is a number, so a number to the 3rd power is a number. It did ask for us to approximate it to, this time, 3 decimal places. So e to the 3rd power, we'll take a look at what that is. E, you can just actually use your keyboard, E, and then raise it to the 3rd power, and you get 3 decimal places, 20.0855. So your 4th digit is a 5, and that rounds the 3rd one up to a 6. So 20.086 for the decimal approximation. All right, and so our second problem has a natural log of 2x minus 5 equals 8. So we have to convert to an exponent. E to the 8th power is equal to the 2x minus 5. Now I'm going to turn that around. 2x minus 5 equals e to the 8th. We would solve this by adding 5. Now, because I'm not going to have you do the decimal just yet, we're going to cancel this out here. 2x is going to equal, and we're just going to write down what we're doing, e to the 8th, and we're adding 5. And then to continue on, we'll have to divide by 2 on both sides. So the 2's will cancel. Our exact answer is x equals e to the 8th plus 5, all divided by 2. So this is the exact answer. Basically, it's just what all of your algebra is. And then we'll do this calculation in Desmos. So e to the 8th power, we can go ahead and do that here. And then we're going to add 5. And then all of that. Make sure that you have all of it that you are dividing by. So we're going to divide by 2, I believe it was. Yes. And our answer is 1492.978. And then there's a 9 after it. That's going to round that 8 up to a 9. 1492.979. So x equals approximately 1,492.989, I believe it was. Let me look at that one more time. Oh, 979, excuse me. Let me change that. 979. That's why we needed to look again. Okay. So if you have e at the start, you convert to a logarithm. If you have a logarithm at the start, you convert to e. The one last twist in this is that just as we had with common logarithms, you have properties that let you go from multiple logarithms to a single. So addition would convert to a single logarithm with multiplication. So it would be, the natural log of a times b. So a single logarithm multiplying the a times the b. If you have subtraction and you have 2 logarithms, I want to try to get that in a different color. If you have subtraction and you have 2 logarithms, you can convert that to a single logarithm. Subtraction will convert to division, so a over b. And then finally, if you have a number multiplied by a logarithm, that number can become a power of the argument, so that you would have the natural log of a with a power of p. So we'll look at solving our logarithm equations, and I do want you to notice that you can only solve if you have a single logarithm on each side. So since this has multiple logarithms, I could use one of my properties. This is one way to do this problem. So going from 2 to 1, I would have the natural log of, and then addition becomes multiplication, 6x, and then equals 0. All right, so some things that happen along the way here. Now we have this single logarithm, so I can convert it to e. My exponent is the 0, so e to the 0 power equals the argument 6x. All right, now, so that's 6x equaling e to the 0. And then on this one, e to the 0 power, if that's something that you do not remember, we can look at that. E to the 0 power is 1. Any number, any base to the 0 power is 1. So we actually have from this point, 6x equaling 1. And then to solve for x, we can divide both sides by 6 to get x equals, and we want it as a fraction, 1/6. So there's converting from 2 logarithms down to 1. And then finally, we have 2 logarithms on this side and 1 on this side. So the 2 over here has subtraction. So this subtraction will change it to a single logarithm with division. So x plus 5 divided by x minus 2. And then on the other side, we have a single logarithm, but this 2 can become an exponent to the 3. So we would have the natural log of 3 with the exponent power 2. All right, now this one has the logarithms on each side. So we are going to cancel those. And that gives us then x plus 5 over x minus 2 equaling, and then our 3 is to the 2 power. So in solving that, we would have x plus 5 over x minus 2 equaling 9. Now to solve that type of equation, we can multiply both sides by the denominator, x minus 2. The x minus 2's will cancel, and so then we have x plus 5 equals, and we can distribute. So that's going to be 9x minus 18. You can subtract 9x from both sides. So that would give us negative 8x plus 5 equals, this is gone, we have negative 18. Subtracting 5 from each side, we get negative 8x equals, and this is negative 23, and then we can divide both sides by negative 8, and we do get a fraction answer. We're just going to leave it like that. A negative over a negative is a positive answer. So 23/8 for that answer. And we do want you to write your final answers in those situations as fractions. So going from a multiple logarithm on one side to a single in both of these cases is necessary before you move on. All right, so this will be for homework 22. Good luck with your homework. Ask questions as you need them.